3.7, number 270, says find f inverse prime at A. Okay, so the function is x plus the root of x, and A is 2. All right, so we know from the formula what the pieces we need to find. F inverse prime at A is the same as 1 over f prime f inverse at A. So again, there's two things. There's the derivative of the original function we need to find. That's not that challenging. Let's just do that right now. F x is 2 power rules. Derivative of x is, of course, just 1. And derivative of root x should be pretty obvious by now, hopefully. I've done enough of these problems. Maybe I'll write it firstly like this: 1/2 x to the negative 1/2, and more appropriately as 1 plus 1 over 2 root x. Okay? So, there's our derivative. And now we just need to plug in here, and for x, we need to plug in f inverse of 2. We plug in f inverse of 2. So to get f inverse of 2, what is that? What is that x? What is that mystery x value that f inverse of 2 is? Well, that's the same as saying f of x equals 2 and solving for x. So to do that, I'm going to take the original function, f of x equals x plus root x, set it equal to 2, and solve. All right, so there's two ways to solve these types of problems, and it may be problem dependent in the textbook how to approach this. One is what I'm going to do now, and that is algebraically solve for it. So usually when you have a radical in an equation, you try to isolate it. So I'll subtract x from both sides, and then you square. So you'll get x equals 2 minus x squared, and that is of course the same as x equals 4 minus 4x plus x squared. And now I solve this quadratic. I always change my radical equations into polynomial equations. So I'll subtract x from both sides, and I'll get 0 equals, written in standard form, x squared minus 5x plus 4, which is readily factorable. So we get 0 equals x minus 4, x minus 1, and so x equals 4 or 1 according to this. But anytime you're solving a radical equation, it's possible that you will introduce extraneous solutions. So if you look back, you take the number 4 and plug it in. 4 plus the root of 4 is certainly not 2. It's greater than 2, right? 4 plus the root of 4 is 4 plus 2, which is 6. 6 is not 2. This is not a solution. Plugging back in 1, you have 1 plus root of 1 is 2. That's true. Okay? So it turns out we're only looking at x equals 1 here. There should not be multiple answers here, and there should be some logical way to exclude all of them except 1 when you're doing these types of problems. Now, the other way to solve this problem, to find out when x plus root x equals 2, is just to look at it. Right? Some of the problems in the textbook, you will not be able to solve the equation you create here, and you should inspect the equation for an obvious solution. Okay? So if you just look at it for a few moments, you'll come up pretty quickly with the fact that x should be 1 here. Right? So either way, do watch out for that. Otherwise, you'll set yourself up for failure. You'll create an equation you can't possibly solve yourself algebraically. when really the answer is probably sitting right in front of you if you just look at it intently enough. So either way, we have x equals 1. So what is this x? This is really f inverse of 2, and that's what we needed to plug in to our derivative. So now we have f inverse, we're doing the formula very quickly, f inverse derivative at 2 is the same as 1 over 1 plus 1 over 2 root of 1. All right? So now it's just a matter of cleanup. So this says 1 over 1 plus a half. 1 plus a half is 3 halves, and the reciprocal of 3 halves is 2/3. So we have 2/3 there. All right? So there's our derivative. And again, be aware of setting yourself up for equations you cannot solve. Be prepared to just look at the equation and find the x value that makes perfect sense.